So, the first one we have is f of x equals x to the power of 7. So if we're going to apply the rule, everything's expressed at the top of the fraction, it's expressed as a single power of n, it's fully expanded, we're ready to differentiate. So we're going to move from the function and we're going to state the derivative function. We're moving from f of x to f dash of x, and f dash of x will be 7. We take that number, we put that out front, 7x to the power of 6. Okay? Can you imagine trying to do first principles for that one? You'd have x plus h to the power of 7, have to do the binomial expansion of that, take a very long time. We've done this in a single step. Now, you absolutely must make sure that you write, here's the function, here's the derivative function. You don't just write equals. Why? Because they're not the same function. This is not the same as this. We've performed a process. This is the function, this is the derivative function. So we're going to be very hot on how you're communicating that here. All right, b, we have a function x to the power of 4. So then the derivative function will be 4x to the power of 3. Okay, c, the function we have is 3x squared. 3x squared. Now, when we have this number out the front, we're just going to multiply it right at the end. All we're differentiating is this x squared part. So the derivative then is going to be 3, that just hangs out. What's the derivative of x squared? 2x, okay? X squared becomes 2x to the power of 1. So we take that power, that comes out the front, 2x to the power of 1. We don't need to write the 1 there, it is obsolete. And so if we're going to simplify this, that would simplify to 6x. Alright, so anytime there's a number out front, it's just going to stay there. Alright, just multiplies it. Okay, let's move on to D. We have f of x equals 5x. Now, I'm going to use both forms of notation. Remember, we have f of x and sometimes we have y. The textbook's going to ask you both. If it says f of x, then you answer f dash of x. If it says y, then what do you answer?
dy.
dy on dx, very good. dy on dx, excellent. So, the rule for this one, we have 5x. Whenever you have kx, okay, where k is any number, the derivative is k. Alright? Whenever you have kx, the derivative is k. So if we have 5x, the derivative will be 5. I can show you why if you want to know, but if we're happy with that. Okay. Yep.
Is it because it's x to the power of 0?
Very good. And any number to the 0 is 1. Very good. Okay, on to E. We have y equals the square root of x. Okay. Now the first step is that we must express everything as x to the power of n. How do we express this as x to a power? Square root of x. Yeah? What did you say? X to the power of half. Remember that from index laws? The square root of x is the same as x to the power of a half. Now notice I've got, here's my function, y. Here's the function, y. It's expressed as x to the n. It's at the top of the fraction. I'm ready to differentiate it. So I'll go dy on dx is, and the same rule applies. That power is coming out front. N x to the power of, we can write it out like this even, n take away 1. Alright, so we're just following the power rule. And then we can simplify it. Okay, half x, half take 1 is minus half. Okay, you get full marks there. the textbook will simplify these ones. Okay, they will simplify ones involving roots. So in order for you to get the same answer as the textbook, it involves a few operations with index laws. But all I want to point out is you've got y, okay, this is the function, and then you've differentiated it. Once you've differentiated it, you can just keep the equals the whole way through, okay? So how's the textbook going to present this? They'll have it as half, and then they'll put the x to the minus half at the bottom, so they'll have x. They'll take that to the bottom, all right, make the negative power positive, and then they'll express it like this, 1 or 2 root x. Okay? So anytime you have x to the minus half, that can be simplified to 1 on root x. We have this half out the front, which means there's a 2 at the bottom of the 2. All right, on to f. We have, the function is 5x to the 4, take away x, take away 3. Okay, we must express everything as x to the power of n. We must have it at the top of the fraction and fully expand. We've satisfied all of those contingencies. We're ready to differentiate. And so we differentiate all of the terms in one step. We're moving from the function to its derivative. Now I've said, when there's a number here, it's just going to hang out. Okay, so it becomes 5, stays there, and x to the 4 becomes 4x to the power of 3. All right, then we have take away, and here we've got x. I've said the derivative of kx is k. Here we have 1x. So the derivative of 1x is 1. All right, and we have a number. Anytime you differentiate a number, it disappears. This minus 3, it just falls off, it's gone. When you differentiate a number, the derivative is 0. So our final answer then will be 20x to the power of 3, take away 1. Now, you can go from here straight to here. This is not a necessary step. You don't need to wait to do the multiplication. If you can see that the derivative of that term is 20x to the 3, you can go straight there. We'll accept both. What else to say? Yep, just again, here's the function, here's the derivative. Being very precise with your notation. You don't just go equals, equals, equals. That and that are not the same function. Once you've differentiated it, they're the same, but you need to be precise with your notation. Very good. Okay, on to G. So I'll clear some room. All right, we've got x to the 4 on top of 5, take away x. And we've got f of x equals, so I'll just go y this time, y equals. So, whenever we have anything on top of a number, we always want to think of that as 1 on 5 times x to the 4. These mean the same thing, right? And all of a sudden it becomes k times x to the 4. It becomes a number out the front, rather than it being a divisor. All right? Now that we've expressed it like that, we're ready to differentiate. All right, so whenever we have dividing by a number, always pull the number out the front, okay? So if we're dividing by 5, that's the same as multiplying by 1 on 5. These will pop up in a bit more too. Okay, let's differentiate then. We've got y, so then we're differentiating to dy on dx. We're going to have 1 on 5 times, so that number hanging out the front, the derivative of x to the 4, 4x to the 3, the derivative of x, 1. Okay, remember here we have one lot of x, the derivative of kx is k, the derivative of 1x is 1. Okay, and that will simplify to 4 on 5x to the 3, take away 1. Okay, so again, observe my notation. Here's y, here's y. Okay, differentiating both terms in one step. Okay, you must differentiate all of the terms at the same time. You can't differentiate half of them now, half of them later. Differentiating occurs all in one go. Okay, on to h. f of x is 3x take 4 squared. Okay, I've said we must express everything as x to the n at the top of the fraction, fully expanded. Alright? This one is not fully expanded, which means we must fully expand this before we can differentiate it. To expand that, we're going to use the perfect square rule. So we have a take b squared, it goes to a squared take 2ab plus b squared. So this term will expand to, I'll do it in a couple of steps, a squared take 2ab plus b squared. We'll simplify it. So that's going to be 9x squared, 2 times 3 times 4, that's 24x plus 16. Okay, notice it's the function which is equal to here, which is equal to here. Everything's at the top of the fraction, fully expanded, x to the power of n, ready to differentiate, all in one go. Alright, 9 times 2x, alright, the 9 just hangs out, doesn't it? Derivative of x squared is 2x. Take away 24. Kx goes to k, 24x will go to 24. So what are we left with? 18x. Take away 24. Alright, on to I, and we have f of x is 3 on top of x to the 5. Okay, express everything at the top of the fraction. This is at the bottom of the fraction. We need to take it to the top before we can differentiate it. So that will become 3x to the minus 5 at the top of the fraction, right? Now we're ready to differentiate it. Let's move to the top. It's expressed as a single power of n. Differentiate in one step. N, x, n take 1. Now, minus 5 take away 1 is minus 6. So that will give us minus 15 x to the minus 6. And keep in mind, when your textbook's simplifying it, they may chuck that back to the bottom and express it like this. Okay, so when you're checking your answers, they'll express it like that or like that. We will accept both. Okay, so you can stop there, that's absolutely fine. Alright, I am going to stop there because the next two are where it's a little bit tricky. I think it's better for you to practice some of the easier ones, see how you go, hope you shred it, and then we can move on to the next couple of questions together when we get up to them. So if we have a look at our checklist, it does start off 15A. Got lots of questions there.